Much, Anya. Thank you everyone for joining online today. It's good to see so many people here to listen to this webinar on the future bitumen specifications. I'll just give a very brief overview of our organization, where I fit into the organization. As Anya mentioned, I'm the technical lead for Eurobitumen. Anya, who's moderating today, is our HSE lead. Our sustainability lead is Brice Delaporte, communication officer Sophia Bitumen, and our office support Veronica Eduardo. And our director general is transitioning from Siobhan McKelvey, who's been with us for a number of years, to Hervé Millet. So that's just a little introduction to the Eurobitumen organization, in case you weren't familiar, and where we all fit into that organization. Now let's have a look at European specifications. What drives our specifications for bitumen? How do we arrive at them? Where are the inputs? And we're going to look a little bit at the history of specifications, because we need to learn from our history if we're going to develop specifications for the future that are more relevant to our product and to the construction works itself. So that could be, for example, the asphalt pavement. So we are driven at the moment by a piece of European legislation called the Construction Products Regulation. The aim of that regulation is to ensure the free movement of products related to construction all the way across the European Union and associated members. It effectively means that it doesn't matter if you're producing bitumen in France or Germany or Malta or Austria, the specifications are the same. So the product should move seamlessly across all regions. Underneath that, the European Commission then sends a request to CEN, the European Committee for Normalization and Standardization. And it is CEN that then drives the process to develop common product standards. Those product standards are then published, and we take into account national requirements, and within that we have national application documents that explain how certain national requirements should be considered. And once those product standards or those specifications are published, we don't leave them alone. We review them on a 5-year rolling cycle. As I said, I wanted to look a little bit at history. We need to look back before we can look forward, because we can learn from our history. And those of you who've seen me on webinars before know that I have a big interest in history, all things historical, but a particular interest in the history of bitumen and how it's applied and tested. So it's kind of logical and normal that I would talk to you about the history of European bitumen specifications. So in 1999, we produced the first common European standard for bitumen. And that was really a historic step forward. Prior to that, each individual country would have their own individual specifications for bitumen, and they were different depending on which country you were in. So in France, we would have the NF T65001. In Germany, it was DIN 1995. In the UK, it was BS 3690 Part 1. And in the Netherlands, it was NEN 3960. So after a long process, we managed to bring together all of those individual country-based standards and produce the first common product standard for bitumen. So it's a big step forward. It took account of the individual nation state specifications. Obviously, across Europe, we have a wide range of climatic requirements. We have extremes of temperature, high and cold, depending on whether we're operating in, let's say, the southern part of Spain compared to the northern part of Sweden. So there was a lot of consensus building that had to take place to account for all of the grades that we needed to incorporate. And we were very successful in doing that. The standard itself complied with the Construction Products Directive at the time. So this was a precursor of the Construction Products Regulation. And our standards complied with that. When you look at it, and I'm going to show it to you in the next slide, it's what I would call a classical table format. And it's based on conventional empirical test methods. Those test methods that we in the bitumen industry have come to know and love over a number of years. So things like penetration, ring and ball softening point, those sorts of empirical tests that have been with us for a long time. And the grades of bitumen, the individual grades of bitumen, are arranged in vertical columns. So it's a relatively easy product standard or specification to understand. This is a snapshot of one of the tables in EN 12591, the specification for paving grade bitumen. I've highlighted a common grade, a 5070 bitumen. It's a pretty common grade across Europe. And so to meet the specification for 5070, we need to ensure that we have a penetration range of 50 to 70. We have a ring and ball softening point range of 46 to 54. When we subject it to short-term aging, we need the binder to retain at least 50% of its its original penetration, and we need the softening point not to increase by more than 9 degrees. And then we have some other requirements on flash point and solubility. But the key takeaway from this is to meet that specification, it's a vertical column. The specification for any grade is read vertically, and to comply with the specification, you have to meet all parts of that, of all of the properties listed in the column. Now, as with all things, when we start to harmonize and produce common standards, it gets a little bit tricky because there are certain local national requirements that need to be taken into consideration. So there is a second table within EN 12591. It's still arranged vertically, but it covers some of those other properties that may be relevant to an individual nation, but are not required for all nations. But again, it's arranged vertically. So again, if you wanted to meet all of the requirements of the individual grade, you would have to meet each of those properties as listed in that second table. Bringing together the individual paving grades was, shall we say, a relatively simple task. It became more difficult when we started to look at specifications for things like polymer modified binders, because there is such a wide array of different binders, of different properties, different requirements that we may need to meet, that it became impossible to incorporate that into that classic vertical format. So we arrive with 14023, the specification for polymer modified binders, which is a framework format. So we don't read the properties in columns, we don't read it vertically, we don't read it horizontally. So what happens is we have classes for individual binders. And I've highlighted some possibilities that you could have here. So let's say if we look at the blue squares, what this says is our binder is a class 3 for penetration. So it has a penetration range of 25 to 55. It has a minimum ring and ball softening point of 55 degrees Celsius, and it has a cohesion value of greater than or equal to 2 when measured at 10 degrees. That's one particular type of binder. The other one highlighted in red has different properties. The important takeaway from this is to understand that this is a mechanism of allowing you to specify your polymer modified bitumen all the way across Europe. What it isn't is a vertical standard, so the grades are not arranged vertically. So if anyone should ask you for a class 2 polymer modified binder, your first question should be class 2 in what regard? Because we don't look down class 2 to specify a binder. We select individual properties. Equally, to remember that this isn't a color chart to allow you to specify some very exotic binders. So it's not really acceptable for someone to come to you and say, I would like a binder with class 8 penetration, class 3 ring and ball softening point, class 6 cohesion, and all of the rest of it. It is not meant to do that. It is meant merely to capture all the grades that we have across Europe. Once we've developed our product standards, as I said, we go through this 5-year revision process, review process. Well, how does that work? If we take from the point of publication of the standard, when it's published by SEN and then also by the individual national standardization bodies, it achieves what's known as a date of availability. And then the clock starts ticking. So after 5 years, we then have a choice. And the question is asked of all the national standardization bodies, what would you like to do? Would you like to confirm that product standard? No changes. Would you like to revise it? Time has moved on in that 5-year period. Is there something else that needs to be added to it? Or is there something that needs to be taken out because it's no longer relevant? And then the final option would be to withdraw the standard. It is no longer relevant, so we take it away and we withdraw it. Usually, we either confirm or revise. And when it comes to the revision, it goes out to all those countries within Europe, and they make their comments through their national standardization bodies and what is known as the mirror committees. And of course, that generates a lot of comments. We then have to have a process to resolve all those comments, because sometimes there are differences of opinion. Once we've resolved all of those comments, we'll then produce a new draft. It goes into the final vote process, and then we have our revised standard, which is published. It's a very idealized timescale. It should only take five years, but it just gives you a view of what happens. So I don't want you to think that since we published that first common standard in 1999, nothing has happened within Europe, because that's not true. There have been new versions of the standards published. So now a question. We have our product standards, we have our specifications. Are they the best that they could be? Or are there some areas that where they could be improved? Well, the answer is yes. Our product standards and specifications could be improved. Why do we want to improve them? Well, they're built on our empirical test methods, the test methods that I said before that we have come to know and love: needle penetration, ring and ball softening point. They are valid in terms of a production control, but they tell you nothing about the performance of the binder, especially when it gets into the construction works, the asphalt, if you like. We only cover short-term aging of the binder. So we only really address what happens to the bitumen as it goes through an asphalt plant. So we only ever deal with short-term aging. So performance is not addressed. Long-term aging is not addressed. Low temperature performance is not really addressed effectively on the basis of the test method, which is in that current product standard. And then if you look at it really subjectively, there are some other areas that the specifications don't deal with. So they don't deal with things like adhesion, and they don't deal with things like water sensitivity. There are good and sound reasons behind that, and that's mainly because adhesion and water sensitivity are a product of two different materials. They're the product of the binder itself and also of the aggregate. So it becomes incredibly difficult to try and base an adhesion method or a water sensitivity method purely on the binder. So let's say there's room for improvement with our current specifications. So is there another way? Can we do it differently? And the answer to that is yes. Where do we look for another way of specifying our binders? Well, we look across the Atlantic and we look to the US, to the United States, and their specification system, known as the SuperPave PG grading. PG, performance grade. It is different to any other specification across the world, and its concept is really quite elegant in that it states that binder properties should relate to service conditions. And that's quite a logical thing to do. When we ask about what we want our binder, what we want our bitumen to do when it's in asphalt, the primary distress mechanism for it is temperature. We need to know that our binder is going to perform at high temperatures in the asphalt pavement, and we also need to know it's going to perform at low temperatures as well. But the SuperPave PG grading doesn't end there. It also covers aging conditions. And if you remember what I had in the slide previously, I said that our specifications don't cover long-term aged binder. Well, the SuperPave specifications do. How did they get there? Well, they started the Strategic Highways Research Program, known as SHARP, SHRP, way back in 1987. It ran for 6 years. It was a significant federal investment, and it was designed to improve the US road network. And it began to be implemented in 1994. Let's just take a pause and context there. This is 5 years before European standards had been brought together on a common basis with that first publication of EN 12591. So it's a measure of how revolutionary the SHARP PG grading system was. But it hasn't been at a standstill since then. It is constantly reviewed and updated. The second phase of updating took place between 2007 to 2017, and implementation of that second phase is ongoing. Well, let's look at climatic conditions. If the SuperPave system requires us to know about climatic conditions, how are we going to achieve it? Well, quite simply, in the US, there are approximately 8,000 individual weather stations that are constantly monitoring either air temperature or, more importantly, pavement temperature. And you can log into these. In years gone by, I have done this. You can get yourself a login. You can find out what the temperature readings are in any particular state, city, whether it's an interstate or whether it's a local road. You can get that information. So 8,000 weather stations, huge amount of data generated. What does it show? Well, if we focus on the high temperature end, so this is the high temperature end. Appreciate it. It's a busy diagram, this, but you should be able to see some bands. So here in the southern part of the US, we have an upper surface temperature of 70. And as we move further north, the upper surface temperature tends to fall away. So we've already started to get some serious information on the high temperature end, and the same is true at the low temperature end. So here we're looking at the low surface temperature of the pavement, and way down here around the sort of Florida, Texas area, we're looking at -10, and then we go up and up and up and up, and we develop these individual bands. So what do the grades, what does the PG grading system look like? Well, all the binders start with PG, and all that means is it's a performance grade. And then 64 is the average 7-day maximum pavement temperature. So over a period of 7 days, maximum surface temperature 64 degrees. And then -22, and this is just an example, says that the expected minimum pavement temperature is -22. So that gives us a range of expected temperatures across the year. When we start to put them into a specification, you will automatically see the difference here. So we have our PG grades running across the top. I've had to simplify this table, otherwise there would be simply too much data on there. So we have our PG 46, maximum design temperature. Then we measure some properties on the individual binder, on the unaged binder, like flash point and rotational viscosity. And then we measure properties of rheological properties, stiffness properties. So for our PG 46, we must achieve a stiffness in the binder, or a complex modulus, of a minimum of 1 kilopascal at 46 degrees. Then we look at our short-term aged binder, and we measure a similar property at 46 degrees and must be above 2.2 kilopascals. And then we look at a long-term aged binder, and we measure low temperature properties in the bending beam rheometer, and we achieve a certain level of stiffness there. Important thing to measure is it's in terms of its structure, is not too far away from our classical EN 12591. The real critical difference is the test methods that are being used, and that's really important. What is absent from the USPG grading is penetration and softening point. They are replaced by rheological parameters that are measured in the dynamic shear rheometer. Why? Because that gives us an indication of performance. I said it has developed. It has indeed. And we're now in a peculiar situation within the US, where you actually have two specifications running more or less side by side. So the AASHTO M320 is the standard specification for performance graded binder. But then there is a second specification, AASHTO M332, which contains the same tests and properties as the original specification, M320, but it builds in an additional test called the multiple stress creep recovery, more relevant for upper surface temperature. The tests apply to all binders. The criteria are always the same, and it's only the temperature that varies. And we have an assessment over those three aging states. So you start to see the difference between the way we have built our specifications within Europe and the way the specifications have been built in the US. Just to show you really where those different specifications are used within the US, there's a bit of a mix. Some states are quite happy with the original specifications. Some are using a combination of the original version plus the new version, and some states have gone completely over to the new specification. So there's a state of development within the US as well. How then can we, in Europe, how can we bridge the gap? How will we get from empirical specifications, which we currently have, to performance-related specifications, which is where we want to be? Well, we have something of a problem because we are required under the Construction Products Regulation to address the performance of the binder in the construction works. And we will also have to incorporate additional requirements such as environmental impact and also release of dangerous substances from the binder. The difficulty that we face is our current product standards are effectively frozen. We can't develop them. We can't go through that 5-year cycle at the moment because we are in a transition period of going towards what's called the CPR acquis process. That's the process to re-evaluate product standards under the new Construction Products Regulation. It hasn't started yet. It's expected to start probably Q4 this year, maybe Q1 2026, and it will see a significant development of our product standards. And I think we all acknowledge that there is room for development of our product standards. We need to think about performance based assessments. We need to address key characteristics, critical aging states, and use the best suitable test methods available to us. Well, Eurobitumen has actually been very active in this. We have had within our organization a task force specifications which has been running since 2017, and originally it was formed to give some input to the revision of the PMB standard 14023. It had a number of different deliverables to consider: the options for 1423, the next steps for 12591, the paving grade, and to develop clear positions that could be adopted through the TC 336 mirror committees, and to consider specification criteria for binders which are not currently covered by product standards. And it also has an indirect input to send TC336. So it's a very valuable organization, and it's produced some very good output. From that has come our position paper, which looks at the recommended characteristics for future specifications. In summary, it says we should have one specification for all binders. That's quite a revolutionary step, and we should address the critical failure states. So permanent deformation, thermally induced cracking, fatigue cracking, raveling resistance, stiffness, and durability. So I'm now going to take you through where Eurobitume's task force specifications believes we should be and which test methods should be incorporated. So if we start with permanent deformation is probably one of the things that nobody likes to see out on the road network. Significant damage to the pavement. It's caused what we call rutting. Water can lie in there. It's a big problem. It's associated with flow or deformation of the binder. We believe that the most suitable test method for that is the multiple stress creep recovery test. So here we are very much aligned with what has happened in the second generation of Sharp SuperPave PG gradings. We're looking at the same thing, same test method. That's a big step forward. In terms of what we look at the non-recoverable compliance, and we look at the percent recovery. We've settled on one specific stress level of 3.2 kilopascals because within our expert committees, we believe that lower stress levels are not applicable for this test. In terms of aging state, we'll measure the multiple stress creep recovery performance on short-term aged binder. Why? Because rutting and permanent deformation tend to occur early in a pavement life. And we set some temperature ranges there which are applicable across Europe. That addresses the high temperature end. What about thermally induced cracking? That's another problem we see. Nobody likes to see cracks like this appear in asphalt. So in terms of binder property, we're looking at the low service temperature. And the test method that we would advocate for that is the bending beam rheometer, EN 14771, and focus specifically on the critical stiffness, where the binder equals 300 megapascals, and to measure that on long-term aged binder. And again, we are generally speaking in alignment with the work that was done in the US. What about raveling resistance? Pavements can deteriorate via raveling and loss of aggregate. And when you focus on that, and you think about what causes that, what are the contributory factors? It's the cohesion of the binder, so how tough the binder is, and also the level of adhesion between the binder and aggregate. Now, I've already said that we can't focus on the adhesion of the binder to the aggregate because it's too difficult, and it's specific to those combinations of binder and aggregate. So it's different. So we focus on the binder. We focus on the cohesion of the binder. Test method, forced ductility, well established. It's in the PMB specification EN 14023, but a critical change here. We advocate for integrating the deformation of the energy under the whole curve, and I'll show you what that means in the next slide, and also measure the elongation to break. And a third critical difference is that we will measure this on long-term aged binder. Why? Because again, raveling tends to appear towards the end of a pavement's life. So it doesn't make a great deal of sense to measure it as a performance indicator on unaged or short-term aged binder. You need to be looking at the long-term aged binder. Just to clarify what we mean, the current forced ductility test only requires us to integrate the area underneath the binder, underneath the curve, from an extension of 200 to 400 millimeters. Well, we're losing an awful lot of data there if we just look at that. So we advocate for integrating the area under the whole curve, because we'll get much more information out of that, and it will be far more relevant to the performance of the binder if we look at the whole curve and the elongation to break. Stiffness, characteristic to measure is viscoelastic behavior. Here we're still under development. A formal position hasn't been agreed, but our focus is on equistiffness temperature as measured in the DSR to give us some critical levels of stiffness related to temperature. And there was some input there when we were looking at options for 12591 some time ago to focus on these equistiffness parameters of 5 megapascals and 15 kilopascals. But at the moment, there is some work to be done on that to finalize the position. We also believe that stiffness, we need to be measuring that on short and long-term aged binder, because the issue of stiffness is very important throughout a pavement's life. And then finally, we come to durability, a similar thing, but here we believe we'll be focusing on the development of equistiffness temperature across a range of aging states. So we'll use those equistiffness temperatures that we're already familiar with, 15 kPa, 5 MPa, but we'll measure the development of those equistiffness temperatures across the aging spectrum of the binder. So what's next? Well, we have where everybody within the bitumen world is waiting for the CPR key process to start, and that will give us our next generation of harmonized standards. We hope that those product standards will be available within in 2030, but that's not an absolute. Because of the way that the process works, it could be a little bit later than that. There's also work going on with a balance of voluntary non-harmonized standards. So all of these test methods that I've spoken about being put into a non-harmonized performance-based standard, which we hope could be available as early as 2027. And then we need to be thinking strategically about specifications for other binders, things like bio-based binders, biomodified binders for reduced viscosity. But we need to keep those on the radar and develop proper, valid product standards and specifications for them. For more information, Eurobitumen has published a lot of information about specifications, about performance-related test methods. There's that position paper, and there's an invaluable source of information about not just the product, but the bitumen industry in our document, The Bitumen Industry, A Global Perspective. You can find those on our website. Just go to eurobitumen.eu, look for publications, look for technical, and you will find the information that you're looking for. All that remains for me really is to say thank you for your attention. I hope this has been a useful session for you. It should have given you a glimpse into the future of bitumen specifications, and also a look back at where we were and where we need, and with a view on where we need to go. If you need more information, you can look at our website. You're more than welcome to contact any member of the team about this. And just before I go, I need to just remind you that there will be a feedback questionnaire that will be coming your way after this webinar. So if you can fill that in, that would be great. We really do value your input on the content and what you want from these webinar series. And with that, I will finish. Thank you.